Assalamualaikum and greeting everyone. Welcome to our final year project presentation. We will be presenting to you our final year project entitled Root Finding for a Nonlinear Equation based on Improvement Newton Method under supervision Dr. Nur Azni Shahari. Our team consists of 3 members, Maizatur Najihah binti Azlan, Nur Ain Nadira binti Muhammad and Siti Nur Amira binti Muhammad Abdul Razak.
For our presentation outline, we will cover 6 parts. Let's start with the first part.
Newton's method is a critical and fundamental technique that converges more rapidly than other techniques. However, Newton's method failed to converge in some instances. To increase the conversion rate, this research uses Newton's method and improvised Newton's method to compare which method is the best. The root finding also implemented in water wavelength model. The outcome of the computation shows that before Newton's method has a smaller number of iterations and shortest average elapsed time. Hence, improvised Newton's method is more efficient in computing in this study.
The most common problem in numerical analysis is determining the equation root in the form of fs equal to 0, where this equation is also known as algebraic or transcendental equation. Generally, most researchers are more interested in implementing the numerical analysis method to solve this equation. Among numerous numerical methods available, Newton method is known as the most powerful method. However, Newton method does not ensure that it always converge. As functions get more complex, Newton method might be difficult to perform the optimal number of iterations. Hence, an improvisation of ordinary Newton method are needed. Therefore, in this study, we are focused on 3 improvised Newton method as stated at the screen. All methods are tested to achieve the 3 objectives in this study. First, to determine the non-zero root finding using Newton method and improvised Newton method, as well as to analyze the accuracy between all methods, and lastly, to apply and compare all methods to calculate the water wavelength approximation.
Next is the literature review on the improvised Newton method. As for summary, we could see that the authors has come up with a better solution using another method throughout years, such as third-order Newton method, variant of Newton method which eliminates the need for the second derivatives of f, midpoint Newton method which strongly believe that it is relevant to use anti-present, and the Chebyshev method. Following with the Newton's method for approximating water wavelength, wave itself may be categorized by wave height and wavelength. Why do we need to calculate the wavelength? This is because wavelength is important to place a lighthouse for towns located near to the coast, and for the sensor that placed beneath the sea in order to give alert when wavelength reaches a risky level. Last but not least, the dispersion relations equations is used to compute the wavelength for various wave periods and water depth.
This is the research framework that we use as a guideline for our study. There are 6 phases involved in this study. Phase 1, mathematical formulation. For Newton method, it derived by using Taylor series expansion. For midpoint Newton method, it has been improvised based on midpoint root for solving nonlinear equation according to the Muhammad 2017. Next, for improvised midpoint Newton method, Alami and Azad 2012 has proposed new iteration by using midpoint Newton method. Lastly, the Chebyshev method procedure was based on Newton method and the expansion of the inverse of the function f as a power series. Phase 2 is selection of suitable function. The function used based on paper Ozia PCETL 2016 involve transcendental function which are exponential, trigonometric, hyperbolic and logarithmic function. Phase 3, calculate the number of iterations for each method. Each function fx will be evaluated with 2 starting values. The number of iterations of the function fx will terminate when the relative error is less than or equal to a specific tolerance. Phase 4, methods implementation in approximation water wavelength. The mathematical model developed in this section to determine the wavelength of the sea by using wave dispersion equation. This is formula after implemented in Newton method, midpoint Newton method, improvised midpoint Newton method and Chebyshev method. Phase 5, verification of the method. The MATLAB programming was used to verify this research. The last phase is compare all the methods. Comparison was made based on number of iterations, average elapsed time and absolute relative error to determine which method have a higher rate of convergence. Firstly, we will show how we use graphical user interface for generating our result. GUI was developed by using MATLAB guide to compare the root of nonlinear equation. Firstly, the user must manually input the information needed, include the function, initial value and maximum number of iterations in the input section. The tolerance of the computation has been fixed up to 6 significant figures. Then, user need to select the pop-up menu button to choose the method. The result for each iteration are presented in the table provided the precise root is specified. Lastly, the user may also plot the function graph by clicking the plot button on the interface. Next, analysis of method in number of iteration. The green color in this table means that it has produced less number of iteration and it shows that midpoint Newton method requires fewer iteration compared to other methods. It means that midpoint Newton method can be utilized successfully and efficiently. Besides, it is critical to select the appropriate initial value. When initial value is selected closer to the root, the fewer number of iterations may be obtained. It can prove from this table for the fourth function where it has an exit root of 2 and initial value 2.1 and 1.75 has been chosen. By comparing these two initial value, the initial value 2.1 produces fewer iterations for all methods than value of 1.75 since this initial value is considered closer to the exact root. Next, analysis of method in average elapsed time. The green color from these tables means that it has faster average time, while yellow color means has longest average time. It shows that midpoint Newton method gives the faster time, while Chebyshev method gives the longest time. As shown in the table before, Chebyshev method outperforms Newton method. However, in this table, Newton method performs better than Chebyshev method. This occurs because the Chebyshev method formula is quite complex, which takes time to converge to the exact root. In conclusion, midpoint Newton method is the best method since it has fewest iteration and shortest average time. Next, analysis of the absolute relative error. This figure shows the comparison of absolute relative error for logarithmic function with initial value 1.8. The absolute relative error midpoint Newton method and Chebyshev method are almost identical. However, midpoint Newton method outperforms Chebyshev method in terms of performance since midpoint Newton method requires 3 iterations while Chebyshev method requires 4. Next, both Chebyshev method and improvised midpoint Newton method require 4 iterations, but improvised midpoint Newton method has the longest absolute relative error to fall from 0.06 to 0.03. It is clear that midpoint Newton method outperforms the other method since it provides significant reduction in absolute relative error and require fewer iterations.
Next is the analysis of the function. Firstly, the exponential function. We use 5 initial value as the x0 for the function as shown. By analyzing the table, we could see that the positive initial value leads to a positive root while negative initial values leads to a negative root. But we could see that the all method used are diverged for 4.5. Divergence of numerical methods happens when the numerical solutions does not approach to exact solutions consistently. The peak root tested in MATLAB might goes off to infinity, negative infinity, and continuously being up and down value without settling towards a value. In addition, we could see that the initial value is far from the exact root. Thus, we can conclude that 4.5 is very poor and non-unique initial parameter values. To sum up, midpoint Newton method gives the best result in generating least number of iterations since it only needs 3 and 2 iterations except for 4.5. Analysis of the hyperbolic function. Since the initial values is used to be tested in the equation as shown. For the exact root, we could see that the bigger root as 10.2 result if using bigger initial root as 9.2. Based on the 6 tested initial values, only one initial value is diverse, which is 0.3. To release that, the divergent series are non-convergent infinite series. This is due to the approximate root xn plus 1, which might sometimes lies on the same side of the root as xn and xn minus 1, and then finally resulting in divergent. As conclusion, based on the analysis made for the study, midpoint Newton method is the fastest method to be tested, and then following with Chebyshev method and then improvised midpoint Newton method.
The logarithmic function is also one of the functions that is used in this study. Based on the figure, the function has 3 exact roots that intersect on the x-axis. However, the selection of the initial value for this logarithmic function is quite constrained since the logarithmic function is defined only for x greater than 0. Overall, the results show that all improvised Newton method are able to outperform the Newton method. However, there are some issues that arise if we look at the number of iterations between midpoint Newton method and improvised midpoint Newton method. When x not equal to 1.75 and 1.8, the results show that midpoint Newton method generate lesser number of iterations than improvised midpoint Newton method. This finding is contrary to Alami and Azad 2012, who claim that improvised midpoint Newton method can converge rapidly and generate less iteration than both Newton method and midpoint Newton method. In conclusion, midpoint Newton method was found to become the superior method among the 3 improvised Newton method used, followed by Chebyshev method and improvised midpoint Newton method.
The graphical user interface, or known as GUI in MATLAB programming, is also used for the purpose of computing the root of the nonlinear water wavelength equation. The number of iterations required for the approaches to converge to the exact root. The application function is x minus d called hyperbolic x, where d represents the water depth entered by the user in the input area. User need to choose method to be applied, then insert the initial value, water depth, frequency, and wave speed as required. The plot button is for the function's graph to be emerged.
Next, all methods were implemented into the estimation of water wavelength to further enhance the result obtained. Before comparing the number of iterations of each method, the study also interested in validating the Lee's hypothesis, which indicate that the shallower the water, the shorter the resulting wavelength. Based on this finding, the wavelength approximation will gradually decrease when the water depth is decreased. Consequently, this finding supports Lee's hypothesis. Moving to the numerical process, study discovered that improvised Newton method yield better approximation rather than Newton method. If all improvised Newton method were compared, studies show that midpoint Newton method require less iteration than improvised midpoint Newton method and Chebyshev method. Therefore, this study research is extended by analyzing the time needed for each method to converge on the actual root. The improvised approach is found to be faster than Newton method. In more detail, the time required for improvised method is within the range of 0.02 seconds, while Newton method is 0.03 seconds. However, among the improvised method, it was discovered that Chebyshev method is the method that can reach faster than the other method. This finding corresponds to the claims stated by Aman and Busquets. On the other hand, it can be seen that the time required by improvised midpoint Newton method slightly slower than the other method. This is because due to the modification made to the midpoint Newton formula, the new formula become increasingly complex, hence delaying the time of convergence. In conclusion, the number of iteration, the accuracy between desired root and the average elapsed time all have a substantial influence on an iterative method performance. In terms of iteration number, improvised Newton method can outperform the Newton method with the rank of midpoint Newton method become the superior method continued by improvised midpoint Newton method and Chebyshev method. In addition, when all approaches were evaluated on the basis average elapsed time, midpoint Newton method remained the best. On the other hand, due to complexity of the Chebyshev method formula, this method cannot perform very well in the comparison of number of iteration as compared to other method. Hence, all objectives in the research have been met.
The fact that this study only focuses on a single transcendental function and only applicable for water wavelength in shallow water, hence future study could be made of merging to several transcendental functions such as exponential and logarithmic function into a single model, or maybe utilizing the benchmark of midpoint Newton method since it is the best method used compared to the other. And for another suggestion, future studies can apply Newton method for the water wavelength in transitional and deep water.
That's all from us. Thank you for your time.